Hello, good morning. Good morning.
Good morning, sir.
Yes, I'm audible now. Yeah, today we'll take up the problems related to queuing theory. In fact, this chapter is based on only formula. Okay, so I'm going to solve some problems. You understand? Only you have to enter the values the type of problem. Nothing to think here. This comes in the unit number 4, along with sequencing. So take a problem now. A self-service store employs one cashier at its counter. Okay, this is the question now. A self-service store employs one cashier, at its counter. Okay. 9 customers arrive at an average every 5 minutes. This is the arrival rate. 9 customers arrive at an average every 5 minutes, while the cashier can serve 10 customers in 5 minutes. Service rate. Cashier can serve 10 customers in 5 minutes. Assume Poisson arrival rate and exponential service. Okay. Hello. I'm audible now? I'm audible?
Yes, sir.
I'm audible, visible?
Yes, sir.
Hello? Hello? I'm audible now? Hello? I'm audible?
Yes, sir.
I'm visible?
Yes, sir. You are audible.
Yes, sir.
Hello?
Yes, sir.
Anybody can say hello?
Hello.
Yes, sir.
Hello? Okay. Right. Okay. So now we will solve a problem now. Okay. So you have to find out the utilization factor and average number of customers in the system, average number of customers in the queue, average time a customer spends in the system, average time a customer waits before being served. So these are 5. I think we may want to ask you for 2 to 3 or 4 questions like 2 marks each, and you have to find the values based upon the service rate and arrival rate. So here the arrival rate is what? 9 customers arrives every 5 minutes. So arrival rate is 9 by 5. And service rate, 10 customers in 5 minutes. 10 by 5. That is 2 customers in per minute. So you have to find out first of all the service rate and customer and arrival rate. Okay. So we'll solve one by one. Very slow, so I have to be, if I'm going to be hurry, it won't take, so I have to be very slowly, I have to operate. Okay, we'll take one by one now. So first of all, find out the arrival rate. Arrival rate. So it is given by lambda. That is equals to 9 customers for every 5 minutes. That is equals to 1.8 customers. 8 customers per minute. Customers per minute. That is arrival rate. Second, service rate. Service rate is given by mu. Mu, that is equals to, so 10 customers can be served at 5 minutes, for every 5 minutes. That is 10 customers for 5 minutes. That is 2 customers per minute. So that is service rate. Customers per minute. Now, so we'll do one by one now. The first question is find out the utilization factor. Utilization factor. Utilization factor. That is equals to lambda by mu. Okay, that is equals to lambda 1.8. 1.8 divided by mu 2. That is equals to 0.9. 0.9. Nothing but you can say 90% is the utilization factor. Okay. So totally system can be utilized 90% time. Okay. This is a utilization factor. Right. So second question. What is the second question? Average number of customers in the system. Okay. Average number of customers in the system. Customers in the system. That is LS. So that is LS system. LS means no customers in the systems. Okay, LS is given by lambda minus mu. This is the formula. That is sorry. Okay, lambda by lambda minus mu. Okay, this is the formula to find the number of customers in the system. So substitute the values now. That is lambda is 1.8 divided by 1.8 minus lambda mu minus lambda. Sorry. You can check out the formula. Yesterday I given the formula. Lambda by mu minus lambda. Sorry, mu minus lambda. So 1.8 by 2 minus 1.8. So that is equals to 9. Okay, so we can say that the average number of customers in systems are 9. Next C. What is the question? Third question. Average number of customers in the queue. Okay. Average number of customers in the queue. Customers in the queue. That is LQ. is equals to LQ is equals to lambda square by mu into mu minus lambda. It's a formula to find the number of atoms in the Q. So substitute the values 1.8 square divided by mu, that is 2 into 2 minus 1.8. So that is equals to 8.1. 8.1. You can say approximately 8 customers are in the queue. Okay. So that's about correct number of customers in the queue. Okay. So I hope you have taken this problem. Okay, it's a simple problem. You have to find out the arrival rate and then service rate based upon the values given. Okay, and find out the customers and all these things. Then you test give a lambda by substitute value going to get 90%. So only thing you have to remember these formulas. That is LS number of in the system, stands for system, lambda by mu minus lambda. And customers in the queue, that is LQ. It's a Q. Lambda square divided by mu into mu minus lambda. That is just you have to multiply lambda by mu, you are going to get this value. So you are going to get this value of substituting. Okay, that's about finding the average number of customers in the system as well as the substitute in the queue. Okay, now we'll do. Okay, now what is the question? Next question, that is D. So you want to find out average time a customer spends in the system. Find the average time. Average time a customer spends. In the system. Is given by Ws is equals to 1 by mu minus lambda. Substitute the value 1 by 2 minus 1.8, that is equals to 5 minutes. That is the time a customer spends in the system, Ws. Second, one more problem is E, that is average time customer spends in the queue. Average time a customer waits in the queue. This WQ is equals to lambda by mu into 1 by mu minus lambda. So substitute the value 1.8 by 2 into 1 by 2 minus 1.8. So we are going to get 4.5 minutes. That's all. So remember here. So I want to remember only these things, that is LS, LQ, WS, WQ. That's it. That's all. Only if you remember these 4. So, and of course, one you should know how to find out the lambda and the mu. That's all. So this question comes for only 8 marks maximum, along with the sequencing. So don't have to worry much about this chapter. So only substituting the values. Have you got any doubt here? You can ask me. Have you got doubt here? Anybody got doubt here? If you say something, I can understand you are there. If not, then I won't think so. You will be there. That's what I feel. Have you understood?
Yes, sir.
Have you understood or not? take one more column. ಕ್ಲಾಸ್ ಇದೆ ಒಂದು ಕ್ಲಾಸ್ ಇದೆ ಆನ್ ಮಾಡಿದ್ರೆ ನವೆಂಬಿಟ್ಟು ಕ್ಲಾಸ್ ಇದೆ ಕ್ಲಾಸ್ 11:30. Yeah, this is the problem now. Arrivals at a telephone booth are considered to be Poisson ratio with an average time of 10 minutes between one arrival to next. Okay, so one arrival to next arrival, there are going to be 10 minutes, and the length of the call is an average of 3 minutes. Okay, length of call is 3 minutes. Now you have to find out what is the probability that the person arriving at a booth will have to wait, and what is the average length of the queue that is formed from time to time. Third, the telephone company will install a second booth when convinced that an arrival would have to wait at least 3 minutes for the phone to be free. So you have to justify the second booth based on the flow of arrivals. Okay, there are sometimes the company has to be convinced to install a second booth when there is a arrival rates are increasing. Okay, so we will solve this problem now. I take class with the So find out the arrival rate. This lambda is equals to arrival rate. Arrival rate. Okay, so 10 minutes between one arrival to next arrival. So you have to find out the rate now. That is to take 60 minutes 10, then you can say that 6 customers arrive at every 1 hour. Next, similarly, mu, that is service rate. Service rate. That is, you can say there is a 3 minute service rate. Average service. So for take 60 minutes, so you are going to get 20 minutes. 20 customers can be served per hour. Okay. So why you are going to do this one? Because basically to find out the rate of arrival rate and rate of service rate. So first question. What is the probability that a person arriving at the booth will have to wait? What is the probability the person has to wait? Okay. So probability you have to find out. Okay. So first of all, first one, probability that the person arriving at the booth have to wait. Probability. Person have to wait. Wait is given by probability. EB is equals to that is equal to lambda by mu, that is equals to 6 by 20, that is equals to 0.37, 20%. It's a probability. Anybody can say trough intensity only, what you are calculating in the beginning. Second question is our length of Q. It is length of Q, LQ. Length of Q. We have taken the already length of Q in the previous problem. Check out the length of Q formula and substitute the values. Length of Q, LQ is equals to average length of Q. Length of Q is yeah, it's not our atoms in the Q. Yeah, this is our length of Q. Sorry. Okay, so the question is so here we are finding the length of Q, average length of Q, average length of Q, formed from time to time, formed from time to time, time to time, time to time. Okay, so that is called as LB is equals to mu by mu minus lambda. So mu 20 by 20 minus 6. 20 minus 6. So 20 by that is 20 or 15. 1.246. That is the length of Q from time to time. LB mu by minus lambda. Next, third question. Okay, third question. So here you have to find out average waiting time within the queue, waiting time in the queue. That is WQ is equals to, you have to find out the lambda 1 now, arrival. I told you that you have to justify the second growth, lambda 1 by mu into mu minus lambda 1. So it is so every time you have to go to wait here, 3 minutes you have to wait to justify the second growth. So that is the mu how much? Mu 20. 20 into 20 minus lambda 1 is equal to 3 to 60. 60 minus 3 lambda 1. 60 minus 3 lambda 1 is equals to yeah, actually 3 by 60 by what happens here if you're going to take 20, so because everything should be in the hours only. Here, this mu is actually in terms of hours, so you have to take 3 by 60 only. 3 by 60 is equals to 3 minutes, 60 by 3, sorry, 60 by 3. You have to convert into hours, no? By 3 is equals to lambda 1 by mu, how much it is? 20. 20 into 20 minus lambda, correct. Now it becomes, how much becomes? Substitute analysis. We're going to get 3 is equals to 20 lambda 1 by 20 minus lambda 1, that is equals to 60 minus 3 lambda 1, that is equals to 3 lambda 1. So that is equals to 60 is equals to 3 lambda 1. So 3 plus 3 are 6. 6 lambda 1. So lambda 1 is equals to how much? 60 by 6. 60 by 6, that is 10 per hour. 10 per hour. Okay, now what happens here? Arrive at 10 per hour. So actually, as per the form, the question that it is arrive at 6 actually. Arrive at 6. So now what happens here? Here there is a increase in flow is equals to lambda 1 minus lambda 10 minus 6 is equal to 4. Okay, so 4 per hour. So justify now because there are 10 customers are arrived now. Actually, arrival rate is 6 only. Okay. So that's how we are justifying the second book. Okay, so hope you understood this problem. We are going to share this one. Understood now? Anybody are there here in the group or just Gayab? You know? Hello. 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 No response. It's the main problem. You know, think you are there or what? Are you there or who is there? Shall I stop the class now?
We are here, sir. Sir, what is meant by patron?
Okay, so there are 5 questions supposed to answer. Patrons arrive at a reception counter at an average of interval of 2 minutes. Okay. The receptionist in duty takes an average of 1 minute per person. One person per time. Now, question is, what is the chance that a patron will straight away meet the receptionist? For what portion of the time receptionist is busy? And what is the average time, the average queue length? What is the average number of patrons in the system? What is the average waiting time of a person patron? Next, what is the average time a participants in the system? These are the 5 questions you have to answer. Okay.
Excuse me, sir.
Same thing. Okay, so same like a previous one, or even previous problem also. Find out lambda and mu. That is arrival rate and service rate. Okay.
Excuse me, sir. Sir. Hello, sir.
Okay.
Hello, sir.
So first of all, find out the arrival rate now. Arrival rate. Arrival rate, that is lambda is equals to, so 2 customers per minute, that is 60 by 2. Because you have to find out the rate, we are finding like this. That is 30 per hour. This arrival rate. Next, service rate. Service rate. Service rate, that is mu, is equals to, I think 1 minute. So 60 by 1, that is equals to 60 per hour. This is service rate. Now, the first question, a patron will straight away meet the receptionist when there is no one in the system. See, the probability that there is no one in the system is P naught. That is, you have to find out the probability. This probability that there is no one in the system. Probability of no one in the person, in the system. No one, sorry. Probability of probability of there is no one in the system. Probability of there is no one in the system. No one in the system. So that you can directly meet the receptionist. The question is, what the probability pattern can straight away meet the receptionist? Means that is, no one should be there in the system. So then directly can go and meet. So that is given by P naught, that is equal to 1 minus lambda by mu. Okay, lambda by mu basically traffic intensity. That is 1 minus lambda 30 by 60. So that is equals to 1 minus 0.5, I think. You are going to get to 0.5. Okay. That is 50% probability that can directly meet the receptionist. Okay. Second, B. The probability that the reception is busy. Okay. What is the probability that this that reception is busy now? Okay. Probability of receptionist is busy. Receptionist is busy. Okay. So once again here it is a probability here. Okay. There is a PB 1 minus lambda by mu only, because lambda by mu is basically traffic intensity. Okay, that is 1 minus 30 by 60. 30 by 60, that is equals to 0.50. that is equal to 50% probability that the section is busy. Okay. Next, third question, C. Average queue length. Okay, average queue length. Average queue length. Already you have studied this one in the previous problem. Average queue length. Okay, that is L is equals to. It's not LQ or LS or WS or WQ, just like I told in the first problem. Basically, it's the average queue length. Okay, it is lambda square by mu into mu minus lambda. Okay, that is lambda square is how much? 30 square divided by mu, that is 60 into 60 minus 30. That is equals to 1 by 2. That is 1 by 2. That's the answer for average queue length. Okay. So I hope you understood this problem. So basically what you're doing is, there are interval days to 2 patterns at a time. So you are finding the rate, that's why you divide by 60 by 2. So we can say at 30 persons per hour, okay, patterns per hour. Service rate to eventually 1 minute. So we can say at 60 patterns can be served for 1 hour, okay, because 1 minute for 1 person. So 60% can be served for 1 hour. That's what you can say, service rate and arrival rate. Now you have to find out probability that there is no one in the system. Means straight away the pattern can meet the receptionist. That's why you can say 1 minus lambda by mu, 1 minus 30 by 60, you are going to get 50% is the probability of directly meeting the receptionist. Second thing, the probability of the reception is busy. Once again, you are subtracting that probability 1 minus lambda by mu only, because the probability is busy. Otherwise, it's going to be busy one. It's 1 minus lambda by mu. So it is 50%. Third question, average length, queue length, average queue length. Okay, the queue is going to form time to time. So the average queue length is L is equal to lambda square. Okay, lambda square divided by mu into mu minus lambda. So 30 square. Okay, 30 square. Okay, divided by 60 into 60 minus 30. That is equal to half. Okay, so this is what the third question. Next, what is the question now? D question. It is D. It is average number of patterns in the system. Okay, average number of patterns in the system. Okay, remember I told you in the first class, this is LS. You have to find out LS is equals to lambda by mu minus lambda. Lambda by mu minus lambda. That is lambda how much? 30 divided by 60 minus 30. Okay, that is 1. Is notepad in the system. Next, ABCD. E. Next, E. That is average waiting time of parts. Okay, in the queue. Okay, average waiting time in the queue. Waiting time in queue. Okay, that is WQ. Okay, I told you. Okay, Q, WQ is equals to lambda by mu into mu minus lambda. Okay, substitute the values. 30 by 60 into 60 minus 30. So that is equals to, check out. So you are going to get 1 by 60. 1 by 60. Okay. Then what you can say 1 minute. 1 minute. Next, yeah. That is average time in this queue system. Okay, that is WS. Average time in the system. The person going to wait. Okay, that is WS is equals to 1 by mu minus lambda is equals to 1 by 60 minus 30. That is equals to 1 by 30. 1 by 30. Nothing but you can say it 2 minutes. Okay, that's all about this problem. So hope you understood these type of problems. So only by substituting the values you're going to get all these things. Remember, entire problem is based upon only lambda and mu only. Okay, these things, if you know it, you can solve any problems. So that's all for today class. So I think we'll take next class. I'm going to take unit number 2, this transportation and assignment problem, where other faculty have also taken assignment. So I'm also going to take the same chapter of unit 2 in the next class. If you have any doubts, you can ask me.
Hello, sir. Hello, sir.
Hello. Hello.
Hello, sir.
Yeah. So this completes queuing theory. Okay.
Yes, sir.
Very easy. In fact, this chapter is relatively easy compared to other chapters because only you have to substitute the values. I think remember here only you are finding the value of lambda and mu. You are finding the rates only, arrival rate and service rate. And also very important, you are finding the probability of two things you have seen in the second and first problem. And average queue length, L, very important, LS, LQ, WS, WQ. These are the only 5 formula you have to remember. L, that is average queue length, LS, LQ, WS, WQ, 5 questions. So normally the question is going to be very easy also, even in the CA exam point of view also, because we can ask only by giving the values of only lambda and mu, you are asked to find out the remaining values only. Okay, that's all for queuing theory. It comes only 6 marks question. So I'm completing this unit 4. So now totally unit number 1 and 4 and 5 completed, left with 2 and 3. So by Monday I'm going to take unit number 2, that is transportation, assignment and travel assessment. So there are 3 chapters in the, of course, basically 2 only. Assignment and travel assessment book comes under the same type only. So those things I'm going to take in the next class, Monday. Okay, that's all. If anything, you can ask me over phone or WhatsApp and all. And this I'm going to share in the Google Classroom. Okay, now?
Sir, you have not shared yesterday's video, sir.
Yeah, I forgot. Today I'm sending. Okay. So
Yes, sir.
immediately I had one more class, 12 to 2. I got immediately got 12 class. 12 to 2, I have got one more class. So I think I have got 10 to 12, 10 to 2 continuous classes. Then 2 to 4:30. I had 2 to 4. I had the test 2 semester, 4 to 5 in meeting. So I was busy yesterday. You can ask me. Don't have to worry. When I'm not doing anything, you can ask me directly or WhatsApp or message me that you are not sending anything immediately. Okay, now?
Yes, sir.
That's all. So good day and see you next week.
Thank you, sir.